Now we will learn about another law of thermodynamics, specifically the second law of thermodynamics. In this course, we will only discuss the following topics. After completing this topic, students should be able to analyze the performance of reversible and actual heat engine, refrigerator, and heat pump cycles based on thermodynamics' first and second laws. First, let us comprehend thermal energy reservoirs. In developing the second law of thermodynamics, it is very convenient to have a hypothetical body with a relatively large thermal energy capacity to supply or absorb finite amounts of heat without undergoing any temperature change. Such a body is called a thermal energy reservoir. In practice, large water bodies such as oceans, lakes, rivers, and atmospheric air can be modeled accurately as thermal energy reservoirs because of their extensive thermal energy storage capabilities or thermal masses. Another familiar example of a thermal energy reservoir is the industrial furnace. Most furnace temperatures are carefully controlled, and they are capable of supplying large quantities of thermal energy as heat in an essentially isothermal manner. Therefore, they can be modeled as reservoirs. Any physical body whose thermal energy capacity is large relative to the amount of energy it supplies or absorbs can be modeled as one. There are two types of thermal energy reservoirs: thermal energy source and thermal energy sink. A thermal energy source is defined as a reservoir that supplies energy in the form of heat. A thermal energy sink is defined as a reservoir that absorbs energy in the form of heat. Now we move to the subtopic of heat engines. Heat engines are devices that convert heat to work. A heat engine should possess the following criteria. They receive heat from a high temperature source such as solar energy, oil furnace, nuclear reactor, so on and so forth. And they convert part of this heat to work, usually in the form of a rotating shaft. They reject the remaining waste heat to a low temperature sink, such as to the atmosphere and oceans. Finally, they operate on a cycle.